Gas giants are large planets that are primarily composed of hydrogen and helium, with smaller amounts of other gases and heavier elements. Unlike terrestrial planets like Earth, gas giants do not have a well-defined solid surface. Instead, they have thick atmospheres that transition smoothly into deeper layers of gas and liquid. Here's everything known about gas giants. There are two types of gas giants in the solar system. Jovian planets, Jupiter-like planets. These are the classic gas giants, which include Jupiter and Saturn. These include Uranus and Neptune, which, while similar in composition to gas giants, have a larger proportion of ice-forming elements such as water, methane, and ammonia. Gas giants are massive, typically much larger than terrestrial planets. Jupiter, for example, has a diameter of 143,000 kilometers, 89,000 miles, more than 11 times the size of Earth, and a mass 318 times that of Earth. Gas giants have deep, dense atmospheres primarily made of hydrogen and helium. In the case of Uranus and Neptune, heavier elements like methane are more abundant, giving them a blue or greenish hue. Gas giants have low densities compared to terrestrial planets because of their gaseous nature. Saturn, for example, is the least dense planet in the solar system, with a density low enough that it could float in water if there were a body of water large enough. Gas giants rotate very quickly compared to terrestrial planets. Jupiter, for example, has the shortest day in the solar system, completing one rotation in just under 10 hours. While gas giants lack solid surfaces, they do have complex internal structures. At the center of most gas giants is thought to be a small, rocky, or icy core, though its exact nature is not well understood. The core might be surrounded by a layer of metallic hydrogen or ice in some planets. Above the core, gas giants have thick layers of hydrogen and helium, which exist in various phases. In the deeper layers, the intense pressure causes hydrogen to behave like a metallic liquid. Gas giants typically have strong magnetic fields generated by the motion of electrically conducting fluids, such as metallic hydrogen, in their interiors. Jupiter has the strongest magnetic field of any planet in the solar system. The atmospheres of gas giants are dynamic and feature a variety of weather patterns. Gas giants, particularly Jupiter and Saturn, have distinct cloud bands that encircle the planet. These bands are caused by differences in temperature and chemical composition at different latitudes. The gas giants are home to massive and long-lasting storms. Jupiter's Great Red Spot is a massive storm larger than Earth, which has persisted for at least 300 years. Saturn, too, has large storms, including a periodic storm called the Great White Spot. Winds on gas giants are incredibly strong. Jupiter has wind speeds of up to 400 kilometers per hour, 250 miles per hour, while Neptune has the strongest winds in the solar system, reaching speeds of 2,000 kilometers per hour, 1,200 miles per hour. The upper atmospheres of gas giants are quite cold, typically around -150 degrees Celsius, -238 degrees Fahrenheit. However, temperatures rise significantly in the lower layers due to the immense pressure. Gas giants are predominantly made of hydrogen and helium. These are the most common elements in the universe and make up the bulk of gas giants, particularly in Jupiter and Saturn. Trace amounts of methane, ammonia, water vapor, and other compounds are present, particularly in ice giants like Uranus and Neptune. Methane, in particular, gives these planets their blue or green color. The clouds on gas giants are composed of different compounds depending on the altitude. For example, Jupiter and Saturn have clouds made of ammonia crystals, while deeper clouds may contain water. All the gas giants in the solar system have ring systems, although they differ in prominence. Saturn's rings are the most famous and the most extensive in the solar system. They are made primarily of ice particles and rock, ranging from tiny grains to boulders. Jupiter, Uranus, and Neptune. These planets also have ring systems, but they are much thinner and darker than Saturn's, consisting mostly of dust and small particles. Gas giants have extensive moon systems, some of which are larger and more geologically active than terrestrial planets. Jupiter has over 90 known moons, including the Galilean moons, Io, Europa, Ganymede, and Callisto. Ganymede is the largest moon in the solar system, larger than Mercury. Europa is of particular interest because its subsurface ocean may harbor life. Saturn has over 80 moons, including Titan, the second largest moon in the solar system. Titan has a thick atmosphere and lakes of liquid methane and ethane. Uranus has 27 moons, the largest being Titania. Neptune has 14 moons, the largest of which is Triton, believed to be a captured object from the Kuiper Belt. Gas giants are not solely dependent on the sun for their heat. Many gas giants generate more heat than they receive from the sun. Jupiter emits about twice as much heat as it receives from the sun due to residual heat from its formation and the slow contraction of the planet, a process known as Kelvin-Helmholtz contraction. Similarly, Saturn emits more heat than it receives, possibly due to the slow separation of helium from hydrogen in its interior, which releases energy as gravitational potential energy. Uranus is unusual in that it emits very little heat compared to other gas giants, suggesting that something has limited its internal heat over time. Neptune, despite being farther from the Sun than Uranus, emits more internal heat, possibly due to ongoing processes in its core. Gas giants are thought to form through two main processes. Core accretion model. This is the widely accepted model for gas giant formation. In this model, a solid core forms from the accumulation of rock and ice in the early solar system. Once the core reaches a critical mass, it begins to rapidly accumulate gas from the surrounding protoplanetary disk. Disk instability model. In this alternative model, portions of the protoplanetary disk collapse under their own gravity to form gas giants directly, bypassing the core formation phase. Gas giants are also common beyond our solar system. Many gas giants discovered around other stars are much closer to their stars than Jupiter or Saturn are to the Sun. These so-called hot Jupiters have very high temperatures and can complete orbits in just a few days. Similar to Jupiter and Saturn, cold gas giants have been discovered in distant orbits around their stars. Some exoplanets are gas giants much larger than Jupiter, with masses up to several times that of Jupiter. Gas giants are fascinating and dynamic worlds, vastly different from the terrestrial planets. Their massive sizes, intricate atmospheric dynamics, strong magnetic fields, and extensive moon systems make them critical to our understanding of planetary science. Moreover, their role in the formation of planetary systems and their prevalence in exoplanet systems suggests that gas giants play a key role in the architecture of many star systems throughout the universe.